In this video, we're going to learn about how to solve a system of linear equations using elimination. So the word elimination means get rid of. So when we're talking about solving a system where we get rid of a variable, we're going to do that by combining two equations. So think about elimination, think about getting rid of a variable by combining two equations. So elimination is the best method when both equations are in standard form and it's difficult to isolate a variable. So that standard form piece, we just need to remember what that is. So we know that standard form is in ax plus by equals c form. So I want both equations to look like this when I go to do elimination. So let's look at some examples and then we'll come up with some steps. So in example 1, we have 3x minus 5y equals negative 16 and 2x plus 5y equals 31. So we notice that they're in standard form, right? My x's are on top of x's, my y's on top of y's, equals on top of equals, and my constant on top of my constant. That's perfect. Our goal, anytime we are solving using elimination, is to have opposite coefficients for one set of variables. So if I look at my x's, I have a 3 and a 2. Those are not opposites. Okay, now we're going to check the y's. I have a negative 5 and a positive 5 for our coefficients. Those are opposites. So I have opposites in my y's. So I'm going to go ahead and I'm going to add these two equations together. 3x plus 2x is equal to 5x. Negative 5y plus 5y is 0. So that was the whole point. It's gone now. Then equals negative 16 plus 31 is 15. Well, now this is an equation that just has x's. That's the whole point, because now I can solve for x pretty easily by dividing both sides by 5, and then we end up 5x divided by 5 is just x, 15 divided by 5 is 3. So I've got the first half of my answer. And just like with substitution, we're going to do the same thing to get the second half of our answer. We are going to substitute our solution back into one of the original equations, and it does not matter which one. So I'm just going to put it in the top one, but it really does not matter. So we would get 3 times 3 minus 5y is equal to negative 16. So again, this 3 is because that's what our x value is. So we get 9 minus 5y equals negative 16. And if I solve this using inverse operations, we end up with y is equal to positive 5. So our solution then, which we could check if we wanted to by substituting our values back in, is 3, 5. So let's take a look at another example. We have, again, we're looking for opposites. So if I look at my A's, we have a 3 and a 5, not opposites. If I look at my B's, we have a 4 and a 2, also not opposites. So in this problem, we're going to have to do a little bit of work before we can combine. We can multiply one or both equations to get opposites. So we want to pick the variable that's going to be the easiest to get opposites. Well, 3a and 5a, it's going to be difficult to get opposites here because I'm going to have to multiply both equations. But if I have a 4b and a 2b, well, that's pretty easy because now I could multiply the second equation to make this the opposite of 4, turn this into a negative 4. So that's what we're going to do. I'm going to take that second equation and I'm going to multiply everybody by a negative 2. We have to be careful because we have to remember we're distributing negative 2 to both sides of my equal sign so that we stay balanced. So negative 2 times 5a is negative 10a. Negative 2 times 2b is negative 4b. And negative 2 times negative 4 is a positive 8. So all I've done is I took my second equation and I multiplied it by negative 2 so that now I have opposites for my b's. I have a positive 4 here and a negative 4 here. So now that we have those opposites, I'm just going to rewrite that first equation down below here. Now that we have opposites, we can add our two equations together. So negative 10a plus 3a is negative 7a. Negative 4b plus 4b is 0. That was the whole point. And then 8 plus 6 is 14. Well, now this is just an equation that you have solved several times. So we're going to divide both sides by 7. And we get a is -2. So we've got half of our answer. So I'm going to substitute our answer of -2 into one of my original equations up here for a. So I'm just going to use this first one, but again, it doesn't matter. So 3 times a, so 3 times -2, plus 4b is equal to 6. Now we're just solving using inverse operations here in a second. So we get -6 plus 4b equals 6. I'm going to add 6 to both sides. We get 4b equals 12. We divide both sides by 4. We end up with b is equal to 3. So our final answer would be -2, 3. So now let's talk about some steps. So over here I put the last example so we can kind of label what's going on. So it looks like the very first thing we did is we multiplied one of our equations, and the goal for doing that was to get opposites. So that is step 1. The next step, if you look over here, is that once we had our opposites, right, we got opposites in our b, we added the two equations together. So that would be step 2. And when you do that, you should remember that a variable should cancel out. If it doesn't, then you probably did something wrong. So once we added our two equations together, we got this, and we just finished here solving for the next, or solving for that variable that's. Next, after we got one of our answers, we substituted that answer back into one of the original equations. So that would be our next step. And then our final step was once we substituted, we just finished up by solving for that other variable. And that would be the steps that we follow in order to solve a system using elimination.